Hello, I'm Karen, and in today's video I'm going to be sharing with you the quantum measurements, and I'm using my crochet blanket as like a visualization to help you actually understand where I'm coming from. Okay, so this bit in the middle is obviously the beginning. This is where we've made our pieces to go around, and here you can see that these pieces, instead of it being an elongated hexagon, it's an overlap of these pentagons. Okay, because I need to move this out of the way, otherwise it's just going to slip off, and I want to show you some other little bits just so you've just seen that I've put a main picture of that blanket on the front. And okay, so in my previous video I was sharing with you the quarks. Okay, so what I was showing you was that we've got the circles represent the positive, the swirls represent the negative. And so I've been doing an experiment with the quarks. Okay, so what I'm going to do is I'm just going to bring you the notepad down. So what I said in my previous video is that I would give you all of the different combinations that I've been able to find. And so if we have a look here, actually what I'm going to do is I'm just going to drop the camera down a minute. Hang on 1 minute. Okay, that's better. Okay, so this is my list of my charm quarks. And as you can see, what we've done, so I've got 2 negatives and I've got 2 positives. So we've got positive and negative, just so because as far as I'm concerned, the quarks are made of 2 pieces. They've got the glue-on bits obviously in the middle, but what they can do is they can separate. So on my list, I've got all the different ones that I've actually called them, and you can see that we've got here, this one in particular is a positive and a negative combination, and which is what this one was that I showed you at the beginning. It's positive and negative combination, but this one's, we've got one is a positive and one is a negative. Just so you can understand where we've come from with the maths of that, is if you try and think about the people having babies is my easiest way. So if you've got 2 positive parents, they can actually have a negative blood grouped baby, and that is because they carry the negative gene. Okay, so these are all my different ones that we've got, different ones. And so when I found that I'd got a supersymmetry one, I realised that that was actually really quite important, and so I've used that as the basis of what I've been trying to do with my calculations. And so that's those bits there, and I came to 12 different combinations of that. So let's just imagine, so you remember I showed you at the beginning, we've got the circle in the beginning. So what I'm going to do, this is just a plain piece, so this would effectively be like a naked quark. So this is where you start from the beginning and you build up around and around. So if we'd got this 6 around there, imagine them spinning and spinning and spinning and spinning until eventually what would happen is that they would all separate. They would then become like a stack of pancakes, for a simplistic explanation, and what we want them to do is to squash back together, and we want a positive and a negative combination. Now if they hit, and what I did is then I realised that you could actually make, so this is a combination of a positive and a negative on one side, and this is equal balanced of the amount. So this bit would be a negative in the middle, this would be a positive on the outside, and then because like I said they're sandwiches, you can swap over the different combinations with them. So this could also have the black yarn here and the white yarn in the background. So I'm using colours just to simplify everything. Okay, it's not that it's, and these are opposite colours obviously. So by doing that, what happens is we end up with 11 more different combinations. I've written all the different combinations down there. So in total, I ended up with 23 different combinations of my quarks, just so that you've got an understanding of where I'm coming from with my background. I still think I might need to move my camera. Hang on a minute. Okay, I feel a little bit better by doing that. Okay, so what I'm going to do is I'm going to share with you my calculations. And so what we're going to look at, so we've got the quantum, so the actual quantum bit itself. So if we just bring over the pieces, so this is the quantum piece. This is a quantum bit. This is the heart. I do believe that that's a quark. and we've got this, which is also a quark. Okay. Oh, and I'll show you my other little bit in a minute. Because we've got this piece. This is what I'm referring to as a baby bit. Okay, so the quantum itself, if that's pushing down or pushing to this, whichever way around you want to look at the universe, the measurement of that is 0.000112. The quantum bit itself is 1/10 of that. The quark has got an uplift of 0.0012, and we've got the measurements of how that is made, which is actually based on the observations of the blanket, which is 5 times 7, which is 35. The heart has a lift of, that's actually 7 zeros before that 2. Okay, so if we want to have one quark, it's held up with 10 pieces of quantum. So what I'm going to do is I'm going to show you just how this works. Right, so this is my quark with my 10 pieces all the way up. So these are my quantum pieces around the outside. So imagine the quark has got a really slow lift of this, and the quantum pieces would push down. So this combination that I've got here, where we've got 7 quantum bits, 10 quantum pieces, and 1 quantum baby bit, that equals 0 gravity. Okay, so that was my measurements for that. And right, so to put this theory to the test, because you already know the gravitation pull of all of the planets, I've used that to be able to prove to you, so that you can then prove to me whether I'm right or wrong. So these are the measurements for all of the different planets. So the Q is equaling this is my quantum, is this piece, yeah. There, so we've got 33,036 times those pieces equals 3.700032, and we can see we've got all of the measurements of all of the planets. I've done all of those, and I noticed that while I was doing that, there was a link. If you see all of these numbers at the end here, they're all divisible by 8. So if I just bring you back the blanket 1 minute. Okay, so you can see that this was my very centerpiece, which has got my 10 quarks, 10 quantum, sorry, all the way around the outside. These are then my quantum overlaps, which obviously you understand about that. And to be able to add on, so each time I make a new quark, I had to add on the maximum of 8 pieces of quantum to be able to hold them together. I'm just going to move this out of the way again. Okay, so now you've got the understanding. So there is, it's a cycle that always has something to do with 8. So when we looked at all of the planets, we can see what the divisions are by 8, and we can see the results are there, which I noticed that that's a total of 34, which divide by 2 is 17, which is a prime number. Okay. I carried on just to be able to make completely sure, and I worked out the Moon, the Sun and Pluto. We still end up with the same results, that yes, they are the correct measurements, but they've still got these divisions by 8 at the end. Those ones totaled to 11, which is also a prime number. So far through my experiment, I noticed that I'd got 11, 17, 5, 7, 23, which was how many quarks, how many combinations I got, but I needed 31, which was I've got to add 8 more pieces to complete the circle of the actual pattern. And the pattern itself had got 361 pieces, which divide by 19 equals 19. So I got another prime number. If you add those prime numbers together, they equal 113, which is also a prime number. So I'd got a total of 8 prime numbers. So then, looking at all of this, we can see we've got the quantum bit, which is the quantum piece, sorry, which is the push of the gravity. We've got the quantum bit, which is 1/10. We've got the quark, which is the uplift, which I've already shared this page. I'm just going round the bend. Right, so my other observations that I noticed when we was doing these, there was only 5 different variations. So I wondered what was those 5 different variations. I've turned them into the periodic table. So you get hydrogen, beryllium, carbon, nitrogen and oxygen. And you do know that if you've got the oxygen gas and you've got the hydrogen gas, if you combine them together, you then get water. So to be able to make the spark is using, and I know it has to be a specific combination to work, but you can get a spark from carbon and beryllium. So they would get the spark, they would ignite the oxygen and the hydrogen to be able to make the water, which would turn into steam, which would then carry the nitrogen, and the nitrogen carries the nucleotides, which is the DNA. So right from the beginning of that Big Bang, at the very, very beginning, it carried all of our information from that point all the way to where we are today. And this is just other observations of calculations. So for the very beginning section where I'd gone to that, so where I'd added one, I'd actually got a total of 6 quarks, and I'd got my edging all the way around it. So to do this, we needed to, so for the 6 quarks, I needed 60 quantum. Technically, I needed more for the pattern that I was doing, but the equations are 60 quantum, 42 quantum bits, 6 baby bits, with 6 quarks makes 0 gravity. Okay, and so what I did was, with all of the different maths I was doing, where's my important number? There. So my leading edge required 60 quantum. And for the quantum pieces, we've got these heart pieces. So these are the outer edge, which I think that the only way I can explain that is it's referring to like the dark energy, because these are all energy pieces. Every single one of them is energy. We've got an up energy, so this is an up energy, and the quantum bits and pieces are a down energy. So I've got 60 of them times, and I needed 5,600 hearts per, so I need 5,600 of these with one of those to be able to create 0 gravity, to balance themselves out. And if I then divided that number by pi, so I times it by pi, which gave me 1,055,544, which divided by 8 equaled 131943, which is also a set of 3 prime numbers. So I do believe I've got the correct calculations. I know that the physicists have been watching you and trying to learn my best. You're trying to find out these math figures, so there you go. I hope that this is going to be helpful to you, and thank you for watching my video, and bye for now.